Investigating the Diffusion of Beads by
Amelia Schrader,
Shruti Alango,
and Beth Feldman.
Our research question was, how does the size of the solvent molecules affect the rate of diffusion of the polystyrene beads? We hypothesized that the rate of diffusion of the beads in the water will be faster than the rate of diffusion of the beads in the water and dish soap due to the difference in size of the solvent molecules of the two solutions. We mainly found that the polystyrene beads in the water and dish soap solvent had a lower speed and thus lower rate of diffusion than the beads in just the water.
We made a systems schema to help visualize the system and all forces acting on the beads. In the first trial, the solvent was water, and in the second trial, the solvent was water and dish soap. The beads are in constant contact with the solvent molecules even though it is unable to be seen.
These results can be explained by our diffusion simulation. In both, we saw that there were larger particles that take up more space in the solution and there are less of them, and this leads to a less conducive environment for diffusion and less collisions with the beads.
Momentum is a main physics idea seen here. Momentum is defined by the product of an object's mass and velocity. It is conserved throughout the system.
In the solution with both the water and the dish soap, if there is a smaller amount of large solvent molecules, there are less interactions or collisions between the beads. This means that there's less momentum that's transferred and there's a lower rate of diffusion and thus a lower average velocity. In the solution with just the water molecules, there's a larger amount of small solvent molecules and there's more collisions between the water and the beads. So there's more momentum transferred between them, and there's a higher rate of diffusion and a higher average velocity.
For our experimental design, we collected samples of the beads in H2O and then a separate sample of H2O and dish soap. We made sure that when we collected the samples that we shook the vials so that the beads in the solution were well mixed. We used the tracker software to measure velocity and position of the beads, and we calculated and compared the speeds of the beads between the two samples to determine the effect of molecule size of particles in the solution based on the speeds. We put the samples on separate slides and we recorded the diffusion of the beads using a video recording software.
The results show that the beads diffused faster in the water than in the water and dish soap. The beads diffuse at a speed of 1.703 micrometers per second in the water and dish soap sample and at a speed of 12.484 micrometers per second in the water sample.
The position versus time graphs show that the position has more change for the beads in just the water because it's more erratic and it shows more elastic collisions taking place over time.
The velocity versus time graphs show that though the pattern of velocity changes between the two samples were similar, the velocity is of a higher magnitude for the beads in the water sample rather than the water and dish soap sample.
Different times between obtaining the samples and recording could have resulted in the solutions settling, therefore changing the velocities found. Movement of the table may have moved the slide, therefore shaking the solution and changing the velocities as well. If the vials were shaken at different rates, it may have also changed the velocities found. Thanks for watching!